Lesson 5, natural logarithmic functions. So the natural logarithm is when you have a base of e instead of a base of 10. And we use ln to show that it's a natural logarithm. So very similar, this is an increasing, this is a decreasing. They have all the same characteristics. The only thing that is different is that this point won't go through 10 and e, or a. What it actually goes through is the point E and A. So somewhere at 2.71 in here is your A. So it's a little bit different in that sense. So we're going to graph the following function, so we have to type it into our calculator. So we're going to type in 5 ln of 0.5. and you should get negative 3.47. Because the log of 1 will be 0, you'll still have your point at 1 and 0. So pause the video and fill in the rest of the chart. So this would be what our logarithm is, and we're just going to plot all of those points. So at negative 0.5, or at 0.5, we're at negative 3.47, somewhere in here. We go through the point 1 and 0, 2 and 3.47, 3 and 5.49, 4 and 6.95, and we can't really get anything else on here. So this would be the graph of this logarithmic function, going through those points. And if you were to put in e for x, so 5 times the logarithm of e, you might have to do to the power of 1, you would get 5. So at 2.718, blah, 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 for infinity, somewhere in here should hit 5, which kind of matches what we're doing. So to determine the x-intercept, y-intercept, and behavior, domain, and range, our x-intercept is x equals 1. Our y-intercept is none. The end behavior, because it is increasing, it goes from quadrant 4 to quadrant 1. The domain is x such that x has to be bigger than 0 for the element of the real numbers. And the range is that y can be anything. So there's all the characteristics of that function. Okay, working with logarithms, we can use this to help us solve for different variables using logarithms or exponents. So use reasoning to determine x in log base 10 x equals 2. So in this one, our x is x, so we'll leave it as x. Our y is 2, and our base is 10. So our base stays as 10, and our y turns to our exponent, so we have x is equal to 10 squared, which means x is equal to 100. So if we were to rewrite this as a logarithm, we would say log of base 10 of 100 equals 2. So that was how you would solve for that. For the next one, we're just going to rewrite as a logarithm. So because this is our exponent goes first in the logarithm. Then we have log base 10. And then this number is the number that goes with our log. So we have log base 10 of 60 is equal to x. So you could even solve that. So if you did log base 10 of 60, you'd get a decimal 1.778 dot 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 dot. So if you typed in 10 yx of log 60, you should get 60 when you answer it. So that's how you would solve for that exponent. And the reason we can do that is because our base is 10. So for this one, this is our exponent. The exponent comes first. Sorry, I'm just kidding. This is the exponent. The exponent comes first in the logarithm. That's what I was trying to say. So this y comes at the end, so we have log base 10 of y. So really, if we wanted to rewrite this fully as a logarithm, we could do 10 to the power of 0.45, and that would be what our y is. So this is how you would rewrite this as a logarithm. Okay, this question asks us to both graph 10 to the power of x and log base 10 of x. So if we were to graph y equals 10 to the power of x, our a would be 1, our b would be 10, our y-intercept would be 0, 1. So the y-intercept is going to go through here. We can make a table of values to figure out a little bit more information. If we type in a 2, we'd get 0.01. If we typed in -1, we'd get 0.1. If we typed in a 0, we get 1. That's our y-intercept. If we type in a 1, we get a 10. So this graph looks like this. It goes up and goes through the point 10. So this is the graph of y equals 10 to the power of x. Now if we were to graph y equals log base 10 of x, we know that our a is equal to 1, so that means it goes through the point 10, 1. And we also know that our x-intercept is at 1, 0. So 1, 0, it goes through 10 and 1, and it hugs the x-axis below. So that is what our graph looks like. And if you notice, these graphs are a reflection of each other. They're actually the reciprocal of each other. They're the opposite. So that is the line of symmetry in the middle. If we were to fold this graph in half, they would completely lay on top of each other. That is how they are related. The same goes for e and natural logarithms. So for the graph of y equals e to the power of x, we know our a is 1 and our b is e. So it goes through the point 0, 1 for our y-intercept. Making a quick table of values, we'd have -2 is 0.135, -1 is 0.367, 0 is 1, 1 is 2.7, and 2 is 7.39. So we'd graph this, it would look like this. Going through 1, up through 2.7, and then 7.39. So this would be our graph. So this is y equals e to the power of x. Now if we were to graph y equals the natural logarithm of x, our a is equal to 1, so that means that it goes through the point e, 1, and it also has an x-intercept of 1 and 0. We could also make a table of values of 0.5 is equal to -0.693, 2 is equal to 0.693, 3 is 1.009, and 4 is 1.386. So at -0.5, we'd be at -0.6, which would be like in here. Goes through our 1, goes through 2 and 0.6, goes through 3 and 1.009, and 4 there. So this would be our natural logarithm. And as you can see, these are also symmetrical in the same way. They are reciprocals of each other. And for the last question, we want to match these to their appropriate questions. So first off, we should determine which ones are exponential and which ones are logarithmic. So because this one goes through the y-axis, this would be exponential. Because this goes through the y-axis, this is exponential. Because this goes through the x-axis, this is logarithmic, and this is logarithmic. So now we can go through and find important information. For this one, our y-intercept is 5. Crosses here at 5. So that means our a is 5. So this function goes with this because it is exponential. And it is increasing, which means that this number has to be a whole number. For our second function, this exponent is exponential. It's decreasing, and it goes through 2, so a equals 2. So this is the function that matches. Our a is 2. It's decreasing because this is a decimal less than 1, and it is an exponential function. Now for our last two, we have a logarithm and a natural logarithm. So this is an increasing, and this one is decreasing. This one also goes through the point 10 and 6. So we know that a is equal to 6, which matches c. So this would be c. And because the last one matches that it is a decreasing function, this last one would be d. If you can't figure it out from those few things that you can look at, you would plug some points into each equation to see if they match.